Today we're going to continue graphing, but we're going to be taking it a step further. First period, I didn't really actually get to the graphing part, so this is going to be a 2-day lesson. Today we're just going to focus mainly on end behavior, but tomorrow we will be graphing, okay? But today we're going to focus on end behavior, how to get end behavior from something in factored form, okay? So for prior knowledge, I want you guys to talk about if a function is even or odd. And so for the even or the odd portion, we look at the exponent. So if you look at the x squared, is 2 even or odd? 2 is, everybody tell me on a count of 3, is 2 even or odd? Tell me in 3, 2, 1. Thank you. And then our x to the third, is that even or odd? Everybody tell me in 3, 2, 1. Odd. Good. And so for even or odd, we saw this on Friday. Do even functions point in the same direction or opposite direction? Even, were they the same or opposite? The same, right? Even is even on both sides, so they're pointing in the same direction. So end behavior points in the same direction. Which means then that the odd ones were pointing in opposite directions, okay? So end behavior points in opposite direction. And so the even functions looked kind of like a U shape pointing upwards, or they could be pointing both downwards. That's even functions. Odd functions, one's pointing up and the other is pointing down, okay? They could also be this direction as well. So even pointing in the same direction, odd, they go in opposite directions. Cell phones put away, people, masks on. All right, so still prior knowledge, what happens when you have a leading coefficient that's negative? So think back at our A, H, and K. This is saying if A is negative, like a -1, what happens to a graph? I want you guys to talk to your partner about this one. Can I have righty side partner? What happens to our graph when our A is negative? Okay. What happens to our graph when our A is negative? Jose Medina?
It starts from the negative side.
Starts from the negative side? I'm not sure what you mean by that.
It goes from negative infinity as the end behavior.
Oh, you're talking about end behavior? Okay, so I'm just talking right now, if my graph was pointing this way, like my x to the third function, and if I had, or x squared, that would be a square because they're even. If I had an x squared function, it's my parent function, right? But then if, let's say for my g of x function, I changed that to negative x squared. What happened to our graph when it was negative? Hannah? It was a reflection. Good. A reflection across the x-axis. So the negative is going to flip the graph and it's going to go point downwards, okay? That was called an x-axis reflection. So whenever you have a negative coefficient, leading coefficient, it produces an x-axis reflection, or like a flip across the x-axis, okay? All right. Next, you have this on your notes. You have 4 just XY graphs on your notes. You're going to be drawing just sketches on your paper. So go draw like on the first one, starting at the bottom on the left side, and then cross, 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 and end up on the right side. Likewise with the second one, start at the top on the left side, and then cross, 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 and end at the bottom on the right side. Just draw a quick sketch. It doesn't have to match exactly like what I have up here. Just draw a quick sketch on your notes. All right, so I want you guys to notice up here, we have the degree. If I have an odd function, meaning like the odd exponent, x to the first, x cubed, x to the fifth, what happens to the end behavior? What does it look like? And if our leading coefficient is positive, what does that mean? So if you guys think back to what we did for end behavior, the first part, x is positive, x is negative, that talks about the left and the right side. And then the y portions of the end behavior tells you if it's up or down. So because x is positive, that tells me that's the right side. Y is positive, that tells me it has to go upwards. So if I look at the graph over here, my right side is pointing upwards, okay? And then the second portion says x goes to negative, that's the left side. Y goes to negative, that means it's pointing downwards. And I can see on the graph, the left side goes downwards. Okay? And then if I look at an odd negative function, so odd, meaning like if I have x cubed, x to the fifth, my exponent is odd. But if it's negative, what's going to happen? Well, what does the negative do to our graph again? You guys just told me. The negative creates a what? A reflection, right? Across the x-axis. So notice that my two end behaviors ended up flipping directions. This time now, my right side actually points downwards and the left side actually goes upwards. So the negative is going to flip my end behaviors in opposite directions, okay? So I can see the right side is going to go down and the left side is going to go up, okay? So right side is now going down and the left side is now going upwards. So they changed because of that negative coefficient. The negative coefficient tells you to switch direction, okay? All right. Let's look now at the next two graphs. Go ahead and copy just a quick sketch. On the first one, just make a W, and on the second one, make like a M shape. Okay. Again, on the first one, or I guess it's the third graph on your paper. The third graph on your paper, you have a W, and on the fourth one, you have like a M shape. Okay. So graphs like this, these are called even functions because they point in the same direction. So this is an even, meaning like your exponent is even, like a 2, 4, 6, 8. And if it's positive, that means your two directions are going to be pointing upwards, okay? So I can see my right side and the left side are both pointing upwards because those are positive y's. So the right side is going up because it's positive, and the left side is also going up because it's positive. So on the graph, I can see the right side goes up, the left side also goes up. That's even, they both go upwards, okay? If I have an even function, but a negative, again, what does the negative do to the graph? It reflects it, That means your end behaviors are going to be pointing in opposite directions. So now the right will go down and the left will also go down. So I have the left and the right side are both going to be pointing downwards because of the negative. So the right and the left are both going downwards. All right, I want you guys to add this on your notes. You guys can either put it on the front, like blue cover of your notes, or you guys have like blank pages towards the end of your notes. Wherever you prefer to put it is up to you. Again, you can do it in the front cover, or you can put it towards the back. You guys have blank pages on your notes. We're not gonna take too much on this part, but like not too much space. You just need to draw yourself like a quadrant. We're gonna be writing stuff on each like quadrant. All right. So first we talked about odd functions. So if I have an odd function that's positive, if my odd function is positive, what's gonna happen? So for odd, do they point in the same direction or opposite direction? Opposite. And then the positive tells you which side the right one goes. So the positive tells you the one for the right side, okay? So because it's positive, that means that the right has to go upwards because it's positive. And then because these have to be opposite directions, that means that the left has to go opposite way, so it's going to go down. Okay, so that's going to be something like this. The right goes up, the left goes down. That's an odd positive. Versus if I have an odd negative, again, the negative is going to be a flip. So they're going to switch directions. The odd, again, tells you its opposite side. And the negative tells you which side the right goes. Okay? That means the right has to go to the negatives, which means down. And because it's opposite, that means that the left has to go in the opposite direction. So instead of going down, it's going to go up. And so for that, it's going to look something like this. The left will be going up, the right will be going down. Okay. Then if I had even functions, so even positive, even is now, instead of opposite, even are the same. They point in the same directions. And then the positive, again, tells you which side the right one goes. So the right goes to the positives. Is that up or down? Up. And because they're the same, the left also goes up. Now, if I had a even negative, even is still the same, but the negative again tells you which side the right one goes. So they have to go to the negative side, which is going to be what? Up or down? Down. And because they're the same, the left has to also go down. Okay? And so for that one, you're going to have something looking like this, both pointing downwards. I forgot to draw my picture for that third one. They both have to be pointing upwards. Okay? So this is going to help us write our end behavior. So if you remember, the end behavior, the x-axis tells you the left or the right side. So if it's the right side, it goes to positive. If it's the left, it goes to negative. And then our y-axis tells you up or down. So if it's up, that's positive, and if it's down, that's negative infinity. Okay? And so after we get all of that, then you can write your end behavior. So your end behavior is going to be like this: as x approaches, comma, y approaches. And you need two of them because we've got two ends of the graph. So this is our end goal, is to write the end behavior like that. Okay? And so if you remember, for the end behavior, the first two pieces tells you left or right. The first two pieces tell us if it's the left side or the right side. And then the last two pieces tells you if it's up or down for the y-axis. Okay? All right, so for example, if I were to fill in the end behavior for this, the right side is which infinity, positive or negative? Right side is positive, and it's going up, so it's up, positive or negative? Positive. And then the left side, the left is which infinity? Negative, and it's going down, which is also negative, right? So for my end behavior, I would write positive infinity, negative infinity, negative infinity. Okay? So let's look at some examples from an equation this time. So on Friday, I gave you guys the end behavior and I gave you guys the zeros. But today, we have to figure out the end behavior. So in order to do that, we need to figure out if this is like even or odd, positive or negative. Okay? So you have this on your notes. You don't have to copy it down. That's already there for you. So we need to first figure out the degree. So our very first step is to figure out the degree of the function. So the degree of the function tells you this is x to the what power. So to figure that out, we're going to count our x's. I have 1, 2, 3 x's because when I multiply them together, like if I were to multiply these two, x times x, that's going to give me an x squared. These last two will produce like an x squared trinomial. And then with that x minus 5 in the front, if I multiply then those two, that's going to end up giving me an x to the third power, right? After I multiply, that'll end up giving me an x to the third power. So the way you can do it is basically just count how many x's you have. You have 3 x's, so that's 3x to the third power. And so because that's an x to the third power, that tells me this is going to be an odd function, right? 3 is odd, and odd means my two end behaviors have to be pointing in opposite directions. Then the second thing I want to do is look at my leading coefficient, my a value. So my a value out front, I'm just checking right here in the very beginning, like right after the equal sign, I have that negative right there. That tells me that's a -1. So my leading coefficient, because of that negative, tells me that this is negative. Okay? This negative right here tells me this is a negative leading coefficient. And so let's go back to basically what I had just talked about. Negative tells you which side the right one goes. So negative tells you that the right side has to go down to the negative. So I have to go down because it's negative. And then the left side has to go in opposite direction. So the left, instead of going down, it has to go up. And then for my end behavior, I'm going to look at this part. The x, the right side goes positive. the left goes to negative. And then my y-axis tells you up or down. So up is positive, down is negative. Okay? So for my end behavior, I have this first part as x goes to the right. So as x approaches, the right side is which infinity? Positive. Comma, y approaches down. And down is negative. And then for the second one, as x approaches the left is which infinity? Negative, comma, y approaches up is which infinity? Positive. Okay? And that's my final answer because my goal was to figure out what the end behavior is. Determine the end behavior of the function. Okay? So one more time. To do this, I had to first figure out the degree. So I had to figure out that that was a x to the third. How did I know this was x to the third? Lefties, tell your partner. If you remember, what does that squared mean? The squared means I have x plus 4 to the squared means I have that binomial 2 times, right? This means I have x times x plus 4 times x plus 4, right? That squared means you have 2 of the binomials. And so because I have 2 of them, I really have 3 x's here, okay? So that means this is going to be x to the third power, which is then an odd function because 3 is odd. And odd means opposite or the same direction. Opposite. Then I need to figure out a. So for step 2, I now need to figure out what my a value is. Bless you. So look right after the equal. I don't have anything there, so it's implied to just be a 1. And so that means that this is positive, which tells me that the right side has to go where? Because it's positive, it goes up. Good. And then the left side has to go in the opposite direction, so the left has to go down. So for my end behavior now, we're just going to write it out. As x approaches, the right side is which infinity? Positive. Y approaches, upward is positive. And for the second one, as x approaches, the left is which infinity? Negative. Y approaches down is which infinity? Negative. And that's our final answer there. Okay? All right. Can I have you guys go ahead and practice the next example? All right. So in this example, I have f of x is negative x times x minus 1 times x plus 2 to the second power. All right, so for my degree, the first thing I need to do is this x to the what power? So remember the squared means I have 2 of those, right? This is a 1x, x to the first, and it's a x squared. So I have a x to the first times x to the first times x squared. That's going to end up being x to the 4th power, okay? So to the 4th, is that even or odd? Even, which means then my end behavior has to be same or opposite? Same. And then I look at my a value. So step 2 is an a value. A is negative. That's a negative 1, which means it's negative. which tells me the right side has to go where? Down. And because they're the same, the left has to go down. Okay? So for our end behavior frame, we have as x approaches, the right side is which infinity? Positive. Y approaches down is negative. And as x approaches the left is negative. Y approaches down is negative. Okay? Not too bad, right? You just need to figure out the even, odd, positive, negative part, and then the rest of it kind of just goes together. All right, let's look at the next example. X minus 8 to the second power, x plus 5 to the second power. All right, so notice this is a x squared. So I have x squared times the x squared is going to give us x to the what power? Fourth power. So my degree here, x to the fourth, is that even or odd? Even. And does that mean the same or opposite? Same. And the a value out front after the equal is just a 1, which means positive or negative? Positive. Which tells us the right side has to go up. And the left has to go in the same direction, which means it has to go up. And then just fill in the blanks as x approaches, y approaches. As x approaches, y approaches. Can I have a lefty side partner? What are the infinities going to be there? All right. Any volunteers here? Volunteer? Oh, thank you. I was like, Nancy, you're volunteering? Jamie, thank you. Snow. The infinities. Yeah, or you can just tell me all of it.
Okay, so the positive infinity to positive infinity, and then the next one would be negative infinity to positive infinity.
Okay, good. We got positive, positive, negative, positive. All right, good job. All right, the rest of the period, you guys need to try the last 3 examples. And then that's it for me for today. You guys are not going to have any homework today, but the rest of the period, you guys are working on those last 3 examples, okay? I'll be walking around to helping you guys as needed.